Welcome back. We're going to now talk about, in our CCIE Data Center Nexus switching main class, we're going to talk about VDCs, or virtual device contexts. So virtual device contexts are really used to virtualize the physical hardware of the Nexus 7K platform. Now, these are loosely analogous to SDRs, or secure domain routers, in iOS XR, or contexts in a Cisco ASA adaptive security appliance or firewall. But one of the things is that VDCs also virtualize the control plane protocols that are used in this 7000 series switch. So these are not analogous to VLANs or VRFs in any way. Okay? What we are actually doing is separating the complete control plane per VDC. Now, what we're doing with this, we're not actually virtualizing the operating system. So this is not similar to running virtual guest machines on, like a hypervisor type platform like VMware. So this is not multiple instances of the Linux server that is controlling the entire 7000 switch. What this is dividing everything up into these separate virtualized control plane, and actually moving the different data resources, the data plane resources, the physical ports within a given blade. We can actually partition up the individual ports to these different virtual device contexts. And what I mean by that, we talked earlier about the port groupings. And we're going to show how, when we create and provision our VDCs, our virtual device contexts, how they will follow the port grouping, follow the ASIC or switch on chip that they're mapped to. So we can't really break the ASIC boundary up, but we can break an individual module up into different port groupings and break those port groupings up into different VDCs. So with the separate control plane function, one of the things that we want to discuss is the fact that VLAN 10, let's just say as an example VLAN, is in VDC 1, the first virtual device context that we might, and I'll probably stop saying virtual device context at some point and just keep saying VDC. VLAN 10 or VLAN 20 or VLAN 1000, whatever we create in one VDC, is not equal to the same VLAN number in another VDC. Now, this would only be if we are not linking these VDCs together. And we're going to take a look in just a moment at some use cases and why we might want to actually link these individual VDCs together. We'll take a look at some different topologies. We'll take a look at our physical topology behind me here in a moment and show how we've done it for most of our pre-provisioning, for most of the demonstration and command line really activities that we're going to be going in throughout the week. But then we'll also take a look at why you might want to do it in a few different topologies in a production or even a lab environment. So if we want to link VDCs together, if we want to actually use data plane traffic between them, then we do actually have to provide a physical cable. And cable, really, even if have cut up the individual resources within a card into different VDCs, we need to then change or we need to connect the line cards together with a physical cable. So if we're connecting two VDCs together, then all of a sudden, of course, we will probably be trunking, and then VLAN 10 does equal VLAN 10 in each VDC, because we are really joining those two VDCs together for whatever purpose we had. But if I wanted to use this in some sort of a multi-tenant environment, one of the use cases we'll go over in a moment, then I could actually reuse all of my VLAN IDs, and they are completely separate from one another. The control planes are completely isolated. And actually, the processes are completely isolated as well. So if I'm running, let's say, OSPF process ID 1 in VDC 1, and we'll probably give it a name, but the way that the system is going to refer to it is really going to be numerically by its ID of 1 or 2, etc. This is not going to be OSPF process ID 1 in VDC 2. or VDC 3 or 4 or 5 or 6, or et cetera. And not only is this not the same process ID from the control plane, the management configuration command line, but there actually is a separate Linux process that's going to be running for the OSPF process, or for EIGRP, or for whatever function it is that we might be doing. So let's take a look at why might we want to use VDCs. So one of the things is I might have logical roles per physical chassis. So for instance, I might want to take and distribute out the very expensive resources of the hardware chassis itself, the multiple redundant supervisors. As Brian talked about earlier, we are in most designs going to have redundant power supplies, redundant supervisors, so the control plane mechanisms, the redundant line cards, M series and F series, and we, with these boxes costing so much, but possibly wanting to perform different functions on them, we might want to do something like, well, let's just say we'll come over here to our whiteboard and we'll say I've got one physical box, which we'll denote with some dash lines. And you'll have to forgive me because of the different members of my family that are artistic. I am not one of the most. So this is our physical Nexus 7000, Nexus 7K. And within here we might partition off different resources. So I might say I'm going to create what looks like a separate physical switch, so an N7K switch, and maybe we'll give it the VDC of 1. And I'm going to create, maybe I actually have another, let's come down here, and I'm going to create N7K2. And I actually wanted to have, one of the things I wanted to have is, I'm just going to erase this real quick, I wanted to actually have 2 physical chassis as well, as you typically would. So let me just draw this dotted line down here. So we've got my first physical platform, and I've got my Nexus 7K second physical platform that we'll just sketch out here real briefly. And so I've got my Nexus 7K 3 and Nexus 7K 4. Now, the naming for this particular diagram is not what we're going to stick with for the rest of the class. In fact, I'll show that. But maybe I want to basically have my core layer between 2 physical chassis here. I'm going to use Nexus 7K1 and Nexus 7K3, for instance. And then I might want to separate out my aggregation layer roles. So I actually, and we'll talk about in the use cases, and one of the reasons why I might actually want to do this with something briefly called OTV, but I might want to have my routing, all my layer 3 routing done at the layer of aggregation. So from aggregation down to my access switches, down to my Nexus 5K switches, I might want to, and typically would use, traditionally layer 2 switching only. So I've got down here, not pictured yet, I'll go ahead and add in here, 5Ks. And of course those 5Ks may have Nexus 2K FEXs or fabric extenders, and they may have multiple links going up. But the idea is that I can partition off virtual portions of my Nexus 7K for use in different logical roles in the data center. Okay, so core, aggregation or distribution, being 2 really words, the same thing, on the same box. That might be one reason. Another reason might be for multi-tenancy. So maybe I'm running a shared hosting environment, a large data center, and I might want to have, or I do have, hopefully, if I have any business, multiple tenants in there. So I might want to take a single Nexus 7000, maybe a 7018 switch, and partition off. Maybe I'll partition entire cards, maybe I'll partition portions of those cards for use with different tenants. Everything is completely separated. The control plane functions, what those tenants are allowed to do. Maybe I'm going to give them access to their own VDC. I won't give them access to a special VDC that we'll look at in a moment called the default VDC, which has really rights over the rest of the box. But they have rights to Telnet or SSH, preferably into their VDC and provision or set up routing and switching for whatever features and functions they need. And everything is separate. If for some reason customer one, and we've installed the licenses, let's say customer one turns on every feature known to man and ends up crashing a few of the processes, or maybe even possibly the VDC for some reason gets brought down. It shouldn't, depending on how we configure high availability, something we'll take a look at in the command line in a moment, it shouldn't affect the rest of the tenants that have other VDCs on that same physical switch. So multi-tenancies is certainly a reason. Another reason might be a test lab environment. As we mentioned, they're very expensive devices. You know if you happen to have any in your data center or workplace, and I might want to reserve one or two VDCs on my physical switch to be able to test out certain features. Maybe currently I'm running multi-chassis ether channel, or VPC, something we'll be talking about a lot more in depth, and I want to possibly transition to a fabric path network for a layer 2, lots of links, or transparent interconnection of lots of links type of an environment, where I'm not even running spanning tree at all. I want to test this out in kind of an isolated environment. Does it really make sense to buy a whole nother switch just to test that out? Well, maybe. It depends on your environment, but maybe you don't have those kind of funds available, and you certainly don't want to put something into production that hasn't been tested. So a test lab environment is another really good use case for a VDC. Also, some features, as we began to talk about and allude to just previously, can't coexist in the same VDC. So one of them is things like OTV, or Overlay Transport Virtualization, basically my layer 2 data center interconnect between multiple data centers. I want to have true layer 2 bridging or layer 2 VPN between data centers. I can't actually have that currently in the same VDC that I have feature interface VLAN turned on, and I actually have switch virtual interfaces or interface VLANs defined. It's not supported. Most use cases that most production cases that I've seen run OTV. They do this at the aggregation layer, where it's still that layer 2 boundary, and then they route in the core. But there certainly are different arguments for maybe even creating almost a new services layer just for OTV. So really I have my aggregation layer, aggregating all my access switches, going up to the core layer, and in between those I have branched off on either side, one for each physical Nexus 7000 switch, so 2 chassis. We're always going to have redundant chassis even. I've got branched off a VDC on each side just for OTV. And then my SVIs are still in my main core VDCs. Okay, something else is F2 series cards. So one of the things that we're going to take a look at is allocating resources in the VDCs, and the fact that I can allocate M1, M2, and even F1 series cards in the same VDC. I, however, today cannot allocate an F2 card in anything but its own VDC. So that's one reason for wanting to do this. If I want to run what's known as a storage VDC or fiber channel over Ethernet, FCOE, I actually need a standalone VDC just for that reason. And I can only have one storage VDC per box. It does count against my overall VDC number that I'm licensed for or have hardware to physically support. And that will be going on, we'll be going into that a lot later in specifically the next class, the storage class. So just taking a look at some of the VDC limitations. We really have 4 VDCs that are available to us in a SOUP 1 card. And we are running a SOUP 1 card. It's what the lab lists. So it's what we're going to be doing in most of our presentation and most of our demonstration and command line. In the SOUP2 and SOUP2E, we have something called +1. So in the SOUP2 and by default in the SOUP2E, we get 4 VDCs plus 1 admin VDC. So this is, and I guess I should go back to the SOUP1 and say, in my default VDC, something we're going to take a little bit more look at the limitations on here in just a moment. Excuse me. We can only do certain things in that default base VDC. Well, customers complained to Cisco and said, I don't want to give, especially if I'm running in some sort of a multi-tenant environment, I don't want to give someone access to a VDC where they could potentially step on other people's toes. In fact, even if we just think about it in a lab type environment, for our particular instance, where we're going to be renting racks out to you, we wouldn't want to give any student access to the default VDC, because then they could potentially take down the whole rest of the box if we're letting another student work on another VDC, for instance. And so Cisco listened to that and said, we'll create an admin VDC in the SOUP2 where it truly only has access to allocating of resources, allocating of CPU, some of the things that we're going to take a look at, control plane policing, setting up system-wide QoS on the box, etc. And then the rest of the VDCs will actually be data plane, data passing VDCs. So the default VDC in a SOUP1 is a full data plane VDC. It passes all data. We allocate resources that we want to use actually as data plane traffic there, as well as provisioning all of the resources for the rest of the system. In SOUP2, that's abstracted, and it makes it for a really nice thing. SOUP2E has the capability to go up to 8 VDCs, but it is an additional license to get there, and that's that asterisk. We have to have that additional license to add 4 more VDCs to the base 4+1. Now, we already mentioned this, there's no internal cross-communication between VDCs. So there is no route leaking like we might experience in VRFs. If we have control plane separation in a router VRF or even in a Cat 6500 and VRFs, we can route leak, or we can route out to the global table. And we can do NAT between these. There is no such communication. There's no real backdoor between data planes or control planes, for that matter, in VDCs. They are a full logical separation. Short of being a separate hypervisor VMware guest, they almost act just like that. Okay, so if we want to connect these, we do actually have to have physical cables. So one of the things we'll talk about, and actually let's just go ahead and take a look at the topology I have behind me, specifically for the different VDCs that we're going to be creating. So here we have, this is the physical topology that Brian began showing earlier. We've got our Nexus 7000, and really this is the switch that we're using here. Okay, so this is an example of the physical switch. What we're going to end up doing is we want to use it for multiple purposes, and to that end, we're going to break this out into 3 additional VDCs. I think I was touching the screen at the same time. So we're going to have the physical chassis, and then we're going to have N7K1. The way that we've numbered this is N7K, pretty standard naming convention across the Nexus platform. N5K, N2K denotes the platform capability or the platform model number itself. And so what we've said is N7K1 dash, and then I'll state something like -2. This is the second VDC. N7K1-3. This is the third VDC. N7K1-4. This is the fourth VDC. And then the way we're going to do this, since we have 2 physical chassis, is we decided to call the second one N7K2-, and we could have said N7K2-1, N7K2-2, 3, and 4. the 1 or the 2 in this position being the switch, physical switch number. The reason we decided to call it 5 through 8, you'll see later when we talk about VPC or when we talk about fabric path and basically creating switch IDs, we wanted to create a very clear and quick delineation and separation between the numbering of each of these switches. So we've basically got 1 through 8. Okay, so we have N7K 1-1 through 4 and N7K2 5 through 8. So we'll be referring to them often as 7K1 or 7K2, 7K3, 7K4. That's all one physical chassis in our lab. And then N7K 5, 6, 7, and 8, those are 4 VDCs in the second chassis. Okay, so also, if I take a look at these 4 physical, this one physical switch, here is the domain for this one physical switch. If I want to look at partitioning these out into VDCs like I have, and I want to connect them together, notice that none of the port numbers overlap. So I don't have N7K 1-1. I've got Ethernet 1/1 through 2. That does not or could not possibly connect to Ethernet 1 through 2 in a different VDC. So one of the things that VDCs do not do is reuse port numbering. So if I say I want to allocate, let's say, Ethernet 1/1 through 8, so Ethernet 1 being module 1, and 1 through 8 being the ports of 1 through 8, if I want to allocate those to VDC 1, which all ports are allocated to the default VDC by default, for the sake of being redundant, if I want to allocate the next 8 set of ports, which is what we're going to do, it does not then reuse the numbering. It doesn't say, okay, well, since you're allocated to VDC 2, I'm going to call that port 1/1 through 8, or 1/1 through, 1/1 through 8, because we're non-canonically counting. It's going to retain the port numbering. So it's going to be E1/9 through, whatever, 17. So if I want to connect Ethernet 1/1 to the second VDC, I actually have to run a physical cable to the other, really to the same blade in the same chassis, but I am logically separating these. Now, in the scope of the CCIE lab, this could be something, Brian and I talked about it, obviously nobody's seen it yet, we don't know, but this could be something that they could even test you on. They would have to have everything cabled. It has been for many, many years now that the candidates have absolutely no contact with, and probably aren't even in the same building unless you happen to be in, let's say, San Jose, or wherever they have the physical setup, at probably San Jose and Brussels. You have no physical contact with, or probably even ability to see, the hardware. You won't be cabling, you won't be responsible for physical troubleshooting or anything of that nature. But they could have everything physically cabled and simply not have the VDCs yet defined, or the resources, the Ethernet ports, allocated to the particular VDC. So this could be one level of complication, or just a level of difficulty in the exam, is that if you just by default went ahead and said no shutdown on all the ports, then you might all of a sudden see really some problem traffic. A lot of ports blocked. Really, you're plugged into your own switch. But as soon as I reallocate these ports to a different VDC, as far as the switch goes, it thinks it's talking to a completely separate switch. There's nothing in the background that says, oh, you're actually talking to the same switch. So let's go ahead and go back to the to our slides, and we're going to go to the command line and allocate these VDCs in a little while. So back on the slides, we're going to say that the default VDC 1 always exists and cannot be removed. This actually is true in the Nexus 5K as well. There is a VDC 1 in the Nexus 5K, it's just that there aren't any additional VDCs. Additional VDCs are a specific feature or function of the 7K platform. The default VDC is used to create and manage the other VDCs. It controls all port allocations, as we've mentioned. All ports, as I just mentioned as well, are allocated to the default VDC at initialization. It's going to control other resource allocations, such as maximum number of VLANs, VRFs, routing table memory. I can actually be very specific on IPv4 unicast and differentiate that from IPv6 unicast or multicast per VDC. So I can create equal or unequal load balances of different things, even such as CPU access. So a minimum amount, it's almost like quality of service for CPU. I can basically say that in a time of congested interrupts and trying to talk to the physical CPU, that this VDC gets a minimum of this percentage share access to the CPU. In the SOUP 1, it can be used for normal data plane operations, and it's recommended for management of the chassis only, which is why in the SOUP 2 they went ahead and changed this. Some of the default VDC only tasks. So there are some tasks that can only be performed in the default VDC, and there's actually a number of them. Some of them are VDC creation, deletion, and suspend. So as I mentioned, let's say you have a lab environment or a multi-tenant environment, and you don't want students or customers, respectively, trampling on other students or customers' configurations, or possibly downing VDCs, deleting them, reallocating resources. Unless someone has access to the default VDC, there's no risk of that happening. You have to be in the default VDC to create, delete, or suspend another VDC. You have to be in the default to allocate interfaces, memory, or CPU guaranteed share. You have to be there to do OS upgrades, and that happens, of course, across VDCs. In-service upgrades or EPLDs, basically task-specific things that can add new features, and TAC-directed as well. ETH analyzer captures, that has to be done in the default VDC. Feature set installation for things, only for some things, such as fabric path, FCOE, or adding the FEX, basically, Nexus 2000 FEX, or Fabric Extender, the remote line cards. Control plane policing can only be done in the default VDC. Port channel load balancing. I can create port channels and utilize them in other VDCs, but if I want to change the default load balancing hash mechanism, then I need to be in the default. Hardware IDS check control, ACL capture function enabling, and system-wide QoS. And we'll talk about some of these in a lot more detail, such as system-wide QoS in the QoS section, or port channel load balancing hash operations in the multi-chassis ether channel, or VPC. So creating VDCs, we're defined in the global. There's no separate admin mode in the SOUP 1. Okay, the host name is actually kind of interesting. It's derived by default from the default VDC host name plus the actual VDC host. So if I'm in VDC host or VDC2, and maybe I've called it VDC N7K1-2, and we'll see this in just a moment, if I'm my default VDC was N7K1-1, my new host name, when I'm in that second VDC, will be N7K1-1-N7K1-2. A little confusing it can be. So there's actually a feature that you can turn off no VDC combined host name. So that's kind of a nice feature that you might wish to utilize. Okay, so allocating VDC interfaces. As we've mentioned, they have to follow the ASIC or switch on chip groupings. I can't just allocate port 1/1 if it falls in a 4-port odd contiguous or even contiguously named group. Okay, so each line card has different limitations based on the ASIC. We showed and talked about those earlier with the iPad app, the Cisco Catalog 3D, and showed how those kind of map to the individual ASICs. So for instance, the M132XP-12 card that the lab has and we have in our lab has a 4-port odd contiguous or even contiguous port numbering, meaning port 1, 3, 5, and 7, because those are all on the top of the card. They use the top riser card, and that's where the ASIC is. They're in group 1. Okay, they share their dedicated bandwidth of 10 gig. And if I wanted, let's say, port 2, 4, 6, or 8. So if I wanted to move ETH 1/1 only to a new VDC, it will let me do it from a configuration standpoint, but it will also tell me that it went ahead and did me a favor and basically followed the ASIC architecture, and it went ahead and moved those other 3 ports for me. I can't split them up even if I wanted to. The F132XP-15 has a 2-port contiguous port groups. I didn't say even contiguous or odd contiguous, so it's not odd numbers or even numbers. It truly is port 1 and 2 are part of the same port group. Port 3 and 4 are part of the same port group, etc. Okay? And as we just mentioned, the parser is going to automatically check and allocate if we make a mistake or just are lazy in our typing. And we'll demonstrate that in a moment. So VDC resources can have defined limits. So I can, as I mentioned, I can cut up and limit VLANs, VRFs. I can limit the number of port channels, span and ER span that can be done. Notice we said ETH analyzer can only be done in the VDC, different than span and ER span, as Brian just demonstrated. IPv4, IPv6, unicast, and multicast, and even module type. As I mentioned, I have to create a VDC all by itself if I want an F2 type, but I can create a VDC that only allows M2 cards or only allows M1 and M2 but no F series. I can be this granular if I have a use case or a need. So these are configured with the limit resource command and VDC resource template in global. So I can actually create a template that applies these, especially if I have maybe 8 VDCs and I want to create the same thing across all of them. I can create a template, apply that to the VDC. The only thing to note is that if I make a change to the template, it does not automatically reapply that to the VDC. I basically need to go, and of course this would be disruptive. Anytime I'm making changes to a VDC, it's going to be system disruptive. So this would be something that I would do at the outset, the deployment of my Nexus 7000 switch, or even possibly at a scheduled maintenance window where I really plan on taking that particular switch down. Some things like in-service software upgrades, I can switch over to another supervisor and make upgrades. We'll be talking about those later, and still run all of my data forwarding functions because of the distributed line cards, even control plane functions and routing protocols and things on the other supervisor. When I'm changing VDCs, this is really going to be a disruptive process. So this is something you'll want to do at a hard maintenance window. So moving between the VDCs, if I want to, I can, from the default VDC, the admin user can switch to other VDCs. And really, I only can use the boldened here, switch to command, if I'm in the default VDC. If I'm in, and this is similar to the change to context command in an ASA. If I'm in, I was in the default VDC, I switched to another VDC, I can then issue the switch back command. I cannot issue the switch back command from another VDC to the default if I SSH directly into that other VDC. That's not supported. That's there's no backdoor operation where I could go into my designated secondarily created VDC and then try to backdoor and get back into the admin VDC. It is secure there. And of course, I'm going to need to use the switch to command for setup of the non-default VDCs, my initial setup. For management of the VDCs, there is something called the CMP interface, the Connectivity Management Processor interface. And this is actually only in the SOUP 1. It was a great idea. It seemed like a really smart, logical idea, but really nobody used it. So Cisco basically cut it out of SOUP 2 and 2E. But this is basically the same as console access to the supervisor, with the difference being that it's actually running a completely separate image. So when we talk about the actual image that runs, the actual universal image that Brian talked about earlier, there's really two parts to it: the kickstart, which gets me the Linux kernel booted up, and then the full image, which brings up all of my different possible features that I can run. And the CMP actually has its own kickstart and full image that I can essentially, it's really a second Linux box running in a very small, there's no features that I can do except for control the rest of the platform. And the idea is that I could even not only perform ISSUs, in-service software upgrades, but I could even reboot the box and still have a full access to, portion of the switch, a layer 3 access to the switch. So this would also be connected to the management switch, or possibly a different out-of-band management switch if I wanted, alongside the physical management interface. Now, speaking of that, there's the physical management 0 interface. This is actually a feature that overlaps between all VDCs. So I'm actually going to give, there's basically a logical separation here of this physical port. So there's one physical management 0 interface per supervisor. Only the active supervisor is, well, active at that time. And I'm going to actually logically partition that physical management 0 interface up. So I'm going to be able to give it a different IP address, and the box will automatically assign it a one-off separate MAC address per VDC. But one other thing to note is that traffic does not leak between management 0 ports. So if I have a management 0 port on supervisor 1 and I have 4 VDCs, I essentially have 4 logical management 0 interfaces, but it's still one physical port. So I'm not going to really be able to, for instance, ping. I can't ping from management 0 in the management VRF from VDC 1 over to the management 0, which is the same physical interface, on VDC 4, even though they have different IP addresses and different MAC addresses. Okay, so this is a limitation, or really something that the system prevents you from doing. Also, management access to the box is really off by default. When I first get in through the console, if I want to be able to telnet, shutter, I know, or possibly SSH, preferred, into the box, I'm actually going to need to turn on even these features. Like Brian said, even something as simple as an interface VLAN, I have to really turn on the feature for. They really tried to create or keep the processes isolated from each other as much as possible to prevent any unexpected things from happening. So each VDC also has its own local user database. We're going to talk next about user rights, and then we're going to go create some of these VDCs. So the non-default VDC users have 2 possible default roles: VDC admin and VDC operator. Admin has all read-write access, but only to that VDC. The VDC operator has read-only access to that particular VDC. There is also, and as we mentioned before, if I SSH or telnet into a particular VDC and I authenticate with those users, I can't switch back to the default VDC. There is no backdoor. Also, the default VDC users, if I switch to a non-default VDC, they inherit the read-write operations of the same user level. So in the default VDC, instead of being called VDC admin and VDC operator for the role-based access control, something that we're going to be talking a lot more about in the security section, and even custom RBAC or role-based access control features and commands and things that we can do custom. I basically have that admin and operator in the default, but it's called network admin and network-operator roles. Okay? And they, as they switch to a non-default VDC, they inherit all the VDC admin or VDC operator roles, respectively. So they inherit their same level of admin or operator role based. And this is not vice versa. So in other words, if I'm a VDC admin, I'm not going to inherit network admin rights. So taking a look at VDC high availability. What to do if, for some reason, an entire VDC crashes, all the processes in that VDC crash? Well, we have different options, some being restart that VDC, bring down that VDC, and don't necessarily bring it back up, not automatically, but has to be done manually, reload the supervisor, or switch over to the standby supervisor. We're going to take a look at when these might occur. So the high availability policy can be different, first of all, depending on single soup. If I happen to, and of course we would never do this, but if I happen to only have one supervisor in the switch, then I'm going to have a particular policy for single soup, what I should do. Or if I have dual supervisors. So for instance, I would never want to, and I don't even think it's an option, I would never want to reload the supervisor just because a VDC crashed if I have a backup supervisor, if I have a standby. I would want to switch over to the standby supervisor, right? But if I only had a single supervisor, then all of a sudden it makes sense that I may want to, especially if this is the default VDC, I may want to actually reload the entire supervisor, even if that causes network disruption. And shame on you for not having a backup supervisor. But it is something that we can configure at an option. I also have the ability to configure different policies, different high availability policies under each VDC configuration. So let's take a look at some of this. We're going to go ahead and connect in to our N7K1, and let's just take a look at show run by default. So show run, I've got my VDC N7K1-1. Now, I think it was called switch by default, but we've gone ahead and renamed that particular VDC. Notice the ID. This is how the rest of the switch is going to refer to this, as ID1. There's different things that we'll talk about throughout the week. One of them that we may go to, probably in the QoS section for sure, I know, will attach to an individual module. I can actually attach to the individual line cards. And when I do things like at a hardware level, and you can be dangerous then, so you have to be very careful when you're actually talking directly to the hardware, kind of bypassing the supervisor. But aside from being careful while we're in there, if we want to refer to a portion or feature or take a look at maybe a show command is what we'll really only be doing. If we attach to a module, we have to also specify what VDC that particular port is in. When we're talking directly to the hardware, we could be talking to a port that is not in the default VDC, but when we attach to that module, we're in the default VDC. We have to change to the new non-default VDC when we're attached directly to the module, but we have to specify what VDC by its numerical ID. So it is important to remember the numerical ID of basically 1 through 4 in our SOUP1 here. Okay, so we can also see from this command line we've got a number of default commands. By default, I have limit resource for module type to M1, F1, and the M1 XL. This is basically the extended forwarding tables for layer 2, layer 3. Because Brian had already done, or I think you did this, yeah, and just I was trying to remember if it was this switch or the second 7K, turned on feature set fabric path. Once I do that, then I can, from this particular VDC, I can allow other VDCs to use that feature set. Fabric path, FCOE being some of those. I can also, and this is what we'll certainly do right now, is I can allocate these interfaces. So we've got these, in fact, if I do a show module, I can see that I have my module 1 is 32 ports, 10 gigabit. It's my M1 32XP module, and module 2 is my 1/10 gigabit, which is my F1 32 port module. So looking back at the allocate interfaces, all of them, Ethernet module 1 and port 1 through 32, and Ethernet module 2, port 1 through 32 are currently allocated to the default VDC. We're going to go cut those up. Then I also have my limit resource VLAN. I have my minimum number of VLANs and maximum. Monitor session, so for my span and my ER span destinations. The minimum maximum number of VRFs, minimum maximum number of port channels that that particular VDC can use, and even things like U4 and U6, unicast IPv4, unicast IPv6, and multicast of those same two versions, how much memory can be used. And keep in mind that without the XL modules and the extended licensing, everything's a license in Nexus, then I really have limited amounts of memory if you take it into consideration, you know, against maybe an ASR type router or something, limited amounts of memory that I'm going to be using for forwarding tables, unless, as I mentioned, I have those larger XL cards and, or, you know, M1, M2 XL cards and the enhanced licensing. Okay, so let's go ahead and we're just going to create some VDCs here. So let's go ahead and we'll say VDC, and we're going to create, one of the things that NXOS does that I kind of like is if I've created a naming convention, it actually brings that into context-sensitive command completion. So I could actually say N7K1 dash and use that as my prefix, and I'm going to say -2, and it's creating the VDC. Give it a moment. It asks politely for. While it's waiting, notice we had that VDC combined host name in here. I'm going to leave that on while we switch to another VDC, and then I'll come back and I'll take that off, and we will see how that has changed things. Because of the time it's going to take to create the VDCs, as we mentioned earlier, for being such a really high powerful, high performance box, it's surprising how long it takes to do a few of these features, like create a VDC or bring them up. That's something else that we can do per VDC is specify the boot order. It actually brings all of the processes up necessary to run the VDC in a particular order, and by default, it's in numerically ascending order. So here we can do things like allocate our resources. So we can allocate interfaces, and so let's just say, for instance, we want to allocate interface Ethernet 1/9 through 16 is what we're going to use for VDC2, and it informs us that moving the ports are going to basically cause them to be removed from the first VDC and could cause a service disruption. We'll say yes. Takes a little bit of time to move them, not nearly as long as creating the resource itself, the VDC resource. And then we'll say the same thing for Ethernet 2, our F1 card, ports 9 through 16. But let's actually just say port 9. Okay, so let's do a show run. And notice that here in my first VDC, allocate interfaces Ethernet 1 through 8, and then it picked back up at 17 through 32. So we had changed 9 through 16. Well, for 2, I had 1 through 8, and then I had moved port 9, but it actually moved port 9 and 10, leaving only the next port being 211. So if I take a look at VDC N7K1-2, it moved, as I told it, 9 through 16 because I followed a port grouping for the first one, but for the second one I only said 2-9. It went ahead and moved 10 because it's a 2-port contiguous port grouping. I will go ahead and move 2 through 16 because that's actually what we're going to be using for the second VDC. So we've basically broken up out of a 32 port divided by 4, which happens to be the port group mapping, but also happens to be, so 4 ports to a port group mapping in M card, 2 ports to a port group mapping in the F card. We also have 4 VDCs, so we're basically allocating 8 ports per VDC per line card. Okay, so this should have taken effect, and I now have 9 through 16 on both ETH1 and module Ethernet 2. Okay, notice I have the boot order here. So the default VDC is always going to come up first. There's nothing we can do about that. And it really wouldn't make any sense to change the boot order for the second VDC until I've created an additional VDC. We notice that we can limit resources for all the different things that we talked about, the module type. So I could say module type F2 only if I wanted. By default, it does put them all in the same M1, F1, M1XL module type allocation. Okay, so really this is all that we need to do except for looking at, within the VDC, except for looking at the high availability policy. So let's say high availability policy, and we're first going to start with single soup. So what happens if this particular box or system only has a single soup? Well, we have the option to bring down the VDC altogether and have to manually bring it back up, assuming it's not the default VDC. We can reload the supervisor because we only have one, or we can simply try to restart that non-default VDC. So let's say we want to bring down, not that that's necessarily the best policy, but just as a non-default example, bring down the VDC in the case of a VDC crash. And if we happen to have a dual soup, and the reason it allows us to go ahead and provision this is because when it's doing the command structure, it's not necessarily looking in context to how many supervisors do you have installed. And maybe later I add a second supervisor, I can go ahead and pre-provision the high availability policy for when I actually add that. So for a dual soup, maybe I want to restart it. The default is, as you might imagine, to switch over to the other supervisor. So let's do show run VDC. And I can see that I've got the high availability policy for single soup is bring down. It did not include the dual soup policy. Reason being is that I already have, that is the default already. Okay? So let's go ahead and I'm just going to end out of my configuration, and I'm now going to switch to VDC, and I'm going to switch to VDC2, and it's now in the initial configuration dialog. So this is a completely separate system. Do I want to enforce secure password or password strength check? No, I don't. What's the password for admin? Enter it again. Do I want to enter the initial configuration dialog? Of course, we never do. And notice the host name. Okay? So if I wanted to do something like, let's say, turn on feature for Telnet, notice that it's not an option here. Let's go ahead and switch back to the default VDC. And of course, I wasn't in config T, so that actually could have had a little bit to do with it. Let me switch to that VDC again, config T, feature, Telnet. I can configure Telnet for one VDC, and I could go to a different VDC and allocate, let's say, SSH only. Okay, but it is per VDC that I need to turn these on. So I can end out, and then I'll do a switch back. Notice that there is no switch to command. As we mentioned, from one VDC, I cannot switch to another VDC. So I can switch back. What happens if I telnet directly into, you know what, I haven't set up the management IP address yet, so let's go ahead and switch to that VDC again and do show IP interface brief or just show interface brief. And the management interface is not configured yet, so let's go ahead and go into the interface management 0, and we'll configure the IP address of 192.168.0.72. So the idea is our numbering convention or IP address convention will typically follow for this class. It will follow the VDC number. First of all, the last octet, the host address is 7 for the platform, and then 2 for the VDC. And one of the reasons we chose to use 5, 6, 7, and 8 for the second physical box, so that I can have number 75, 76, 77, 78 as an IP address or a switch ID or whatever it is that I'm using, even maybe a MAC address if I want to change from the burned-in address, whereas I don't have host 725, 726, or even 721, something like that. Okay, so we'll do this, /24, and no shut that. and I should be able to show CDP neighbor and be able to see from management 0 my DC rack management switch, and should be able to telnet to that second device now. Now I don't have my users defined. So I did have in 7K1-1, I had a user defined for Mark. And we have one for Brian. Or if I was just setting up from the beginning, I of course would have to add these. But here I'm going to have the one that I had just set up from the console, from the default VDC, really in the console of the box, in the default VDC, and then switch to the second VDC I created. I've set up that single user. There is going to be the admin by default user. I just have to get in with that. And I've got a little script there that does logging monitor 7 for debugging. But other than that, if I notice, I can't really switch back. So I might tell it to switch back. I have the command there because the parser doesn't differentiate between whether I telnetted in or consoled in, but I'm not actually going back to the default VDC. So if I want to set up my users, I actually have to go set up all those users separately. As we mentioned, a separate user database. So here I will go ahead and switch back. I switched over to this first tab where I was in the default VDC and switched to the second VDC. And I'll go ahead and say config T and no VDC combined hostname. So now I'll end out and I will switch to VDC and I'll choose -2. And notice now that my host name is nice, neat, concise, and it even went ahead and changed it on my telnet session, even while I was sitting there telnetted in. So nice feature there. We'll probably run for the rest of the class with no VDC combined host name. Okay, I can exit out or switch back. I'm in the default VDC 1-1. So let's talk about saving the configuration. If I want to, first of all, there is no shortcut for write. Okay, so this is, Cisco's been saying they're going to deprecate it and do away with it in iOS for a long time. It's still there in most iOS platforms. It is not an option in NXOS. I do need to copy run start. I can do copy run start, or I can say the whole running -config, startup -config. And I also have another option. I can either hit carriage return, and if I do so, it will only save this VDC. Currently, I'm in the default VDC to NVRAM. But I can also say VDC all. I can give it that argument and save all VDCs to a binary file. Now, actually, if we take a look, let me just back up here a little bit so it doesn't perform this config. If I do show boot flash, dir boot flash, I can actually see that I have different directories for the different VDCs. So there really are separate places in Flash, even in NVRAM, that the different configurations for the different VDCs are kept. So if I'm over here in telnetted into the 7K1-2, the second VDC, which for all intents and purposes is a completely separate switch, I can actually I want to be back out here and I just want to say copy run config to startup config. Notice I don't have the VDC all. So again, I'm isolated, I'm in a sandbox, I'm securely partitioned off from the rest of the box, and I can't affect any default operations for the switch, including saving everyone's config at once. It is a very nice feature from the default VDC to be able to do copy run start for VDC all. And it does take a little bit of time to go ahead and generate this configuration. I've got a little hash marks here, indicator of when it's doing it. Even once it gets to 100%, we'll notice that now it's taking a little bit of time to actually write it to, that was really just a compilation of the configurations for all VDCs, and now it's writing it to the NVRAM.